Assalamualaikum warahmatullahi wabarakatuh. My name is Jufri HANINI bin HASAN. Today I would like present about design and printing of origami structure with a fused deformation modeling 3D printer. Now we go to introductions. What is origami? Origami is the art of paper folding, which is often associated with Japan's culture. In modern usage, the word origami is used as an inclusive term for all folding practice, regardless of their culture of origin. The century-old art form of origami and kirigami could offer elegant solution. However, this technique not been applied in additive manufacturing application. This project introduced a folding techniques from origami to evolve from flat material to the additive manufacturing. Application deploy states a review of recent origami and kirigami techniques used for this purpose will be done to understand their underlying mechanism and create physical model to demonstrate and compare their feasibility. Here we go to problem statement. The non-linear physical-plastic behavior of fold complicates the modeling of an origami structure mechanical properties. Next, material limitation restrict the fold, which is not proper for origami structure with non-negligible fold thickness or maximum curvature. The same folding structure is used for most of the origami model available in the market. Then origami folding technique have not been applied in additive manufacturing application before. For the objective, to design various origami structure from different folding techniques and to simulate and study the folding mechanism of the design origami structure. Next, scope. This project focused on designing and printing origami structure with a fused deposition modeling 3D printer. This technique have not been applied in additive manufacturing application before this. Thus, this project introduced folding technique from origami to evolve from flat material to deploy states for the additive manufacturing application in the case of study. The CAD model was designed using CAD designs, reducing product development cycle time and applying origami structure design to the fused deposition modeling 3D printer. For literature review, this chapter discusses topics related to the AM and the design and printing of origami structure with a fused depositions modeling 3D printer. The process of joining material to create a 3D model is known as AM. The AM working principle includes the 7 basic steps. It starts with the generation of CAD model of the design, followed by the conservations, CAD to STL file, STL sizing, machine setup, 3D printer process, removal process, and post-processing, type of folds, and mechanism. To understand, this chapter talk about ABS, FDM is applied in various fields. The field include lightweight machinery, architecture, medical, and also sport. Next, this chapter explains the design of origami. This chapter also include the printing parameter of the 3D printer, such as the raster, angle, and also the layer thickness. Methodology. This chapter describes the proposed methodology of this research, consisting of the principle of method that will be performed to complete the research. The selection of material, designing, processing, and testing will be presented after referring attentively to the specification and particular of previous research. The main methodology suggests suitable method, recommended tool, and technique to complete this research. Here, this my flow chart, the planning. Sketching drawing. do a some sketch of the design of model. The sketch of drawing will generate the idea of the product and apply some type of sketching. This is a flat plate origami structure sketching. Now CAD design. First we go to ORIPA software. ORIPA software is a drawing software dedicated to designing crisp pattern of origami. The unique feature of ORIPA is calculation of the fold shape from the pattern. The software applied for define and calculate fold should be put on designs. This is make it fold line and calculate the fold can be possible for this pattern. This SolidWorks. SolidWorks software is a mechanical design automation application that lets designer quickly sketch out idea, experiment with feature and dimension, and produce model and detailed drawing. Origami structure design will be designed in this software. This software can use STL or standard tessellations, triangulation, Lagrange is a 3D file format which use a series or triangle to describe the outer surface of 3D model. So origami structure design can apply to additive manufacturing, FDM. This is a origami design on SolidWorks. So ANSYS or Origami Simulator, complete solution for design engineering simulation with all steps from geometry creation to optimization and result generation in single modern, easy to use environment, minimizing engineering change order and maximizing design alternative and ideations. Use Origami Simulator to define movement, and origami can fall very well or fail. This platform also can simulation sets up several type of constraint, distance, prevent the sheet from stretching or compressing, and angular constraint for sheets. Origami movement can be like this. This ABF filaments, good dimension stability to build origami structure. This acronym ABS is used by 3D FDM printer and comes in the form of long filament wood around a spool. Operating the 3D printer is a very simple. That's why we use it. FDM. We use FDM to print this project. The FDM system is specialized for this project. Okay. Maybe we use Odyssey X2 machine in this FDM machine, used to build test specimen for this project and use ABS material. And now I expect it can apply origami concept to EM, can understand the underlying mechanism, and able to various origami structure can be produced in FDM, then can create physical model to demonstrate. That's all. Thank you.